The boiling of wort primarily serves to concentrate the malt extract by evaporating excess water through boiling, ensuring the wort reaches the desired density. This process is crucial for producing beer with a full-bodied and well-rounded flavor. Additionally, boiling effectively deactivates enzymes present in the wort and eliminates potential microbial contaminants, thereby stabilizing the wort's composition and preventing spoilage. In subsequent fermentation stages, the next critical step involves the addition of hop bittering agents. Following the principle of first bitter and then aromatic contributions, bittering hops are added initially to extract isoalpha acids, which impart a refreshing bitterness to the beer. Later, aromatic hops are introduced to retain volatile aroma compounds, giving the beer a distinctive floral fruity or herbal aroma profile. Furthermore, the high temperatures during boiling cause proteins in the wort to denature, which facilitates their binding with polyphenol from hops and malt, forming flocculent precipitates, often referred to as hop-break solids. Removing these impurities significantly enhances the beer's non-biological stability, reducing the likelihood of haze or sediment formation. Additionally, calcium ions in the water react with phosphates in the malt to adjust the pH, promoting the precipitation of beta-glucans and lowering the final pH of the beer, resulting in a more balanced mouthfeel and improved stability. Boiling also volatilizes and expels undesirable hydrocarbons responsible for off flavors, thereby improving wort quality. Once boiling and coagulation are complete, further separation of hop-break solids is required, details of which will be covered in our next video. Follow Tiantai to learn more about beer brewing.